the last mile to the urban park. Our research took place in Nanjing, an important city located in eastern China. By 2022, there were about 603,100 disabled people here. In this city, urban parks have a limited number and services range. It is difficult for disabilities to enjoy the park as ordinary people. However, rapid metro development and a better barrier-free environment may help more disabilities to enjoy the park. This is why we chose this topic. We want to know what will happen in the last mile from the metro to the park for disabled people. We chose Nanjing Metro Line 3. This is the range of metro services crawled by Python 3.7. There are 5 stations people could get to the urban park within 15 minutes. We investigated these stations and their routes to nearby parks. And these routes will be divided into indoor and outdoor parts. The indoor part starts when people get off the metro, including the platform, station hall, and ground of the metro station. People use escalators, stairs, elevators from the platform to the station hall. Then check in and choose ordinary exit or elevator exit in different directions to reach the ground. The barrier-free environment along the way from the various exits to the park is the outdoor research content. In order to discuss the different needs of different groups for accessibility, we divided the groups into people with mobility impairment and people with vision impairment. The following is a detailed description of the research. Firstly, we will present the indoor part. For the people with mobility impairments, they better need barrier-free ramps and barrier-free carriage signs to help them get on and off the metro cars. When going up and down stairs, they tend to use the elevator and wheelchair platform lifts. Of course, there may be unavoidable steps on some routes. Accessibility signs can help them find their way easier. They need special wheelchair gates or green channels to check in. This table shows the results of the 5 stations. Most of the stations are friendly to people with mobility impairments, while the exit at Nanjing Station has 17 unavoidable steps. Then, let's have a look at the situation of people with vision impairments. They rely more on voice broadcast when getting on and off the metro. Voice broadcast is also required when using elevator and escalators. Instead of worrying about the width of the elevator doors, they are more concerned about whether there is braille on the elevator button or the stair railing. Of course, the tactile paving is also important. But the investigation shows that only a few carriages are connected to the tactile paving, and there is no sign to tell them which carriage they need. We can see from the table. The escalator lacks voice broadcast. The main problems of tactile paving are occupied or color is indistinguishable. Generally, the indoor barrier-free environment is basically perfect, and it is more friendly for people with mobility impairments. The metro exit is the boundary between indoor and outdoor parts. As people arrive at the exit, our survey comes to the outdoor part. As the metro station has different types of entrances in different directions. These 5 stations involve a total of 11 outdoor routes. The exit can be divided into 2 categories, elevator exit and ordinary exit. Both types of exits are commonly used by disabled people. The elevator exit involves ramp width, ramp slope, ramp material, handrail height, ramp tactile paving. The ordinary exit involves step number, step height, handrail height. After exiting the station, people enter the sidewalk. There is tactile paving which people with vision impairments focus on. During the investigation, we found that the tactile paving has the following problems. Indistinguishable color. Unsafe material. Frequent turning. Incomplete coverage. Occupied due to the unreasonable location design. Occupied due to the occlusion of trees. And other different kinds of problems. On both ends of the sidewalk, there is the major concern for people with mobility impairments. Curb ramp. Curb ramps on most roads are up to standard. But not every curb ramp is standard. And not every sidewalk has a curb ramp at the end. Among these 11 routes, 9 require people to cross the road, 4 of them twice. With reference to the national standard, the average speed of a disabled is 0.8 meters per second. According to the road length and green light time calculation, 67% of the green lights meet the needs of disabled people. But in addition, the lack of voice broadcast will make it impossible for people with vision impairments to cross the road independently, so they have to ask for help. Unfortunately, none of the crossings in our study were equipped with voice broadcast systems. For wheelchair users, the final barrier to access the park is whether the park has an accessible entrance. But, in fact, half of all parks do not have accessible entrances. That means wheelchair users will still be turned away from the park, even if they finally reach the park. Combined with the table of survey results, we can see that for people with mobility impairments, 7 routes have problems with curb ramp and access. And for wheelchair users, every problem is a real barrier. For people with vision impairments, the tactile paving has different problems in completeness, standardization, accessibility, and so on. And each problem will cause inconvenience and danger to people with vision impairments. Combined with the research results and relevant specifications, in order to evaluate the accessibility of the Metro Park, we make the following 4 barrier-free evaluation tables. The table organizes the needs of different people into different evaluation dimensions. Each dimension contains specific evaluation contents. According to the research, 1 point for compliance with the evaluation content and 0 points for non-compliance. Calculating the compliance rate of each evaluation dimension, it can be found that indoor accessibility is good, both groups meet the standard rate of 65% or more. Outdoor is the opposite, compliance rate of less than 60% will have 6. We can also see that the compliance rates of visually impaired people are generally lower. Expanding the evaluation dimension of tactile paving standardization, it can be found that in the evaluation content, the location, color, and warning indicator of tactile paving are the most problematic. Then we scored the 11 roads to visualize their accessibility. This is the formula for calculating the score. The weights in the formula are derived from the AHP analysis. The table shows the results of the calculation. The overall accessibility score for people with mobility impairments is higher than for people with visual impairments. The same is true for the average score. More interesting are the 2 routes G and F. They received the highest score for the mobility impaired and the lowest score for the visual impaired. In other words, both routes are easy for wheelchair users, but difficult for the visually impaired. Thus, it can be seen that the current construction of barrier-free environment focuses more on mobility-impaired people and to some extent ignores visually impaired people. In summary, we propose the following suggestions for optimizing the barrier-free environment. Pay attention to the systematic and standardized design of the barrier-free environment, and avoid those barrier-free facilities that exist but cannot be used. Improve the connectivity of barrier-free environment between indoors and outdoors and different outdoor locations. Ensure the individual needs of different groups, such as supplementing the voice broadcasting system, which is friendly to the visually impaired. Focus on the future maintenance of barrier-free facilities, and prohibit blocking and occupying. Upgrade the geospatial data model, provide personalized route recommendation and navigation for different groups according to the accessibility scores. Finally, strengthen relevant publicity, improve social attention, so that all people can travel equally and easily. The above are all the contents of this report. Due to the limited amount of data and the limited time, the research results are only for reference. In the future, our group still hopes to conduct more in-depth research on accessibility. Thank you for listening. Welcome your criticism and correction. Thanks again.